All right, so it says find the exact values of any relative extrema or 1/2 x minus sine of x from 0 to 2 pi and justify. So since it's saying exact values, we're going to need to be finding both where we have relative extremas and then also the y values that go with them. Okay? So last example, we were more concerned with just the x value. Now we want the y value as well. So we need to find our critical values first. All right. So f prime of x would be what? Right. So we're trying to see where does that equal 0? So where is cosine of x equal to 1/2? Well, if you add the cosine over, it'll be that. So this would be short x. So it'd be that point up here and that point down there. So x would have to be pi over 3, right? And then pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Pi over 3. Right? So these are our critical values. So we need to test around that interval. So you got x, f prime, all right, so what's an easy value we can test to the left of pi over 3? Pi over 2 would be to the right, but we can do that in the middle. That's fine. To the left of pi over 3, what could we use? Even easier. Which is the same thing as, right, 0. Right. So again, 0 is here, right? This would be, and then if you go around, that's 2 pi. So, no, not necessarily. Doesn't really matter, actually. Yeah, I mean, they're still going to give you the same sine value. You're going to plug these into your derivative, right, which would be right here. So if I plug in 0, right, I have 1/2 minus cosine of 0, which is what? Cosine of 0 would be right here. So what's the x value right here? That's the y value. 1, right? So you have 1/2 minus 1, which is negative. And then if you plug in pi over 2, right, 1/2 minus cosine of pi over 2, cosine of pi over 2 is 0, so 1/2 minus 0 is, and then 2 pi is going to be the same thing as 0. Okay, so what do we have going on there? Relative min, and then you have a relative max at 5 pi over 3. All right, so you have a relative min at pi over 3, and then we have to plug in pi over 3 into our original to get the y value that they're looking for. So that's going to be ugly. Why don't we do that over here? So we have f of pi over 3. So you have 1/2 times pi over 3 minus sine of pi over 3. All right, so 1/2 times pi over 3 would be pi over 6, right? Minus sine of pi over 3 would be what? That would be the original. Right, we figured out the x values of where our extrema are at. Now we need to figure out the y values because they want both. Right, you plug that into your original because this is going to be the point on the original equation. So what's sine of pi over 3? Good. And I don't want to simplify that, so we can leave it as that. Maybe. Alright, so we have a relative min at pi over 3, comma, pi over 6 minus radical 3 over 2. Since f prime of x goes from negative to positive at pi over 3, pi over 6 minus 3 over 2. Alright, and then we have a relative max at, what did we figure the relative max was? 5 pi over 3. And then we got to figure out the y value to that one. 5 pi over 3. That's 1/2 times 5 pi over 3 minus sine of 5 pi over 3. So 1/2 times 5 pi over 3 would be 5 pi over 6 minus sine of 5 pi over 3 would be what? Good? Good. So 5 pi over 6 plus radical 3 over 2 since f prime of x goes from positive to negative at that point. Love that trig. Love it, love it, love it. Well, 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 you should probably get on that. If you guys have to take it next year in college, like if you're going to business majors, I have. None of you are going into business? None of you? I'm just saying, if you have to take like business calc your first semester in college, they don't do trig. So they don't. But if you're going more science related, then yes, you're gonna have to do a lot of trig. No, I'm saying like it's gonna be on your AP test, but like if you're going in a more business related direction in college, trig will not be part of the class. Yeah. Yes. Math is a science. What's that? Oh yeah. A lot of this, a lot of physics. Calc? Yeah. All the time. Math. I took a lot of calc, but calculus is just, so I took it's called real analysis. So imagine, remember like when you took geometry and you had to do all those proofs and stuff? So imagine that, but trying to prove calculus. Yeah, it was rough. Oh, it was rough. All right, number 5. Find the relative extrema for x squared minus 4 to the 2/3. All right, what do we know? Where? 2/3, right? Right, and that's because of the 2/3. All right, so that means that the derivative won't exist at 0. So that is another critical value that we're going to have to use. All right, so derivative would be 2/3 x squared minus 4 negative 1/3 times 2x, Mr. Chain Rule. Okay, so that leaves me with 4x over 3 cube root of x squared minus 4. Okay, so where will the derivative is going to equal 0 at 0, and then the derivative will not exist. Where? Right, it would be 2 and negative 2. Okay. So if you have a rational expression, it doesn't exist when the top is equal to 0, right? Right. And then it doesn't exist when you do the denominator, right? So if you set that equal to 0 and solve, you're good. Yeah, we're gonna have to test around 3 of them. Negative 2, 0, and 2. All right, so we can do negative 3, say negative 1, 1, and 3. And again, you are plugging them into your derivative, not your original. All right, so if I plug in negative 3, I will get a negative over negative 3 squared is 9. Well, that's positive, right? Negative over positive is negative. If I have negative 1, that would be negative over, that's negative, right? Positive. Positive over a negative, so that would be negative. And then positive over a positive, positive. All right, so you have a relative max at where? At 0. Since f prime goes from positive to negative at x equals 0. Right? And then you have a relative min at x equals negative 2 and 2. Since f prime goes from negative to positive at x equals negative 2 and 2. You don't have to all the time. If it just says like find relative extrema, they're most likely just asking for the x value. So yeah, they're looking for both the x and the y. All right, where is this function increasing? You're looking for an interval. Right? 2 to infinity. All right, you want to make sure that you're using those values up there. So it's increasing from negative 2 to 0, 2 to infinity, and then it's decreasing from what? Right. So why don't you guys put that one into your calculator? X squared minus 4 to the 2/3. No, I just want to see what it looks like. So you got, yes, x squared minus 4 to the 2/3. All right, so if you have the older calculators, make sure that x squared minus 4 is in parentheses. And when you do your exponent, 2/3 is in parentheses as well. And then hit your zoom button, and then hit number 6 for a regular window. All right, so there's your relative min, there's your relative max, and then there's your other. No, this is just it's because of the window. All right, so cusp at -2 and 2, right? Because that's where we figured out that the derivative won't exist. And then you have your horizontal tangent right there at 0. So when I said there's a cusp at 0, I didn't take into consideration the x squared minus 4 that we're raising. I kind of messed it up a little bit. Yeah, so the cusp wouldn't be at 0. So if it's a regular x to the 2/3, now you get your cusp. All right, so the x squared minus 4 changes it. Probably 80%. Yeah. But again, doing the calculus, you figured out that, you did have the right answer. So. Okay, 6a says find the x coordinates for relative extrema for each of the following. All right, so you got the cube root of k squared times 2k minus 1. So we can do it two ways. We can do it either product rule or we can distribute. Which one do you want to do? All right, so T of k would be what? K to the 2/3 times 2k minus 1. Right? There might, yeah. All right, derivative of the first times the second. So 2/3 k to the negative 1/3 times 2k minus 1 plus k to the 2/3 times 2. So you have 2/3 k to the negative 1/3 2k minus 1. See you, Ellie. Okay. What can I take out? Okay. All right. So you see how they both have like a k variable, right? You want to take out the lower exponent. So now we have to figure out like what else can we take out so that we can rewrite it. Right? So is there any way we can multiply 2/3 to get 2? So well, I'm just thinking if we take out the 2/3, right? What do I need to multiply this by so that I get that? Three. All right. Okay, so we took out 2k to the negative 1/3, right? We're left with 2k minus 1 plus now, what do we need to multiply 2/3 to get 2? 3. And then what do I need to multiply this by so that I get k to the 2/3. Just k to the first. Right? K to the negative 1/3, right? If you were to take that and multiply it with k to the first, right, which is really 3/3, if you add those exponents together, you get 2/3. So we're trying to see, what do I need to multiply this k to the negative 1/3 so that it gives me k to the 2/3? If it's k to the first, right, which is the same thing as 3/3, negative 1/3 plus 3/3 would give you that 2/3. Right, so you got 2/3 k to the negative 1/3, 5k minus 1. All right, so we got 2 times 5k minus 1 over 3 cube root of k. Okay, where does right? I don't know. All right, so where would the top equal 0? One over 5. And then k doesn't exist, or the derivative doesn't exist at 0. Okay. That part. Well, now we got a test. Just saying, you can use your iPad. All right, what value do we want to do to the left? We'll do like negative 1. Okay, and then 1. All right, so we plug in negative 1. That's going to be negative on the bottom, and then 5, that's negative. That's negative, that's positive. If I plug in 1 over 10, that'll be negative and positive, right? So that's negative. And then if you plug in 1, positive, positive. All right, so you have a relative max at what? Relative max at x equals 0. And then you have a relative min at your relative min at 1/5. Yeah, I mean, you can, put some justification in there, but yeah, we're done.